Hello everyone, in this video I am going to demonstrate 4 to 20 milliampere or 0 to 20 milliampere current source controlled by Arduino Uno. I am going to use Arduino PWM function to control the gate to source voltage of the MOSFET responsible for controlling the current source. So as you can see here, this is the setup. I have wired my setup on a breadboard for demonstration purpose. So as you can see here, this is the MOSFET I am using, IRF840. The MOSFET is mounted with a heatsink, and here you can see these are the gate to source biasing resistance. This is a 10K resistance, and here is also one more 10K resistance. I am going to show the circuit soon. So here you can see this is a 48 ohms resistance. So I don't have small 1 watt resistance, so I am using a 10 watt resistance instead. And here you can see this is a 330 ohms resistance. So I'll show the circuit diagram soon. So here you can see from the Arduino Uno pin number 9, I am feeding the PWM signal to the current source. So as you can see here, this signal is fed directly to the MOSFET gate. Let's look into the circuit diagram. So as you can see here, this is the circuit diagram. So here you can see I am supplying 24 volts DC. So this is the point where we need to connect the field device, the actuator, the positioner for controlling actuator or any PLC signal or anything. So whatever we are going to control, we need to connect here. So the device should be a 4 to 20 milliampere or 0 to 20 milliampere compatible device. And we are having a series resistance of 330 ohms. And we are connecting it to the MOSFET IRF840. And you can see here the source of the MOSFET is connected with a 47 ohms 1 watt resistance connected to the ground. You can see here there is a plus 5 volts pull up resistance. You can see there is a plus 5 volts pull up resistance, and here at this point we are feeding the PWM signal from the Arduino Uno directly. So I have just kept a voltmeter here for my reference. So as you can see, this is the circuit diagram. This is the complete circuit diagram. You can see. So this is how we can control 4 to 20 milliamps current, and we can control field devices using Arduino Uno. So this is the way we can control field devices using Arduino Uno. So let us look into the multimeters first. So here you can see I am getting 8.15 milliamps DC. So let us look into the gate to source voltage. The gate to source voltage is 1.33 volts. You can see this voltage is 1.33 volts at present. Between this point and this point, it is now 1.33 volts, and the circuit current is this circuit current is 8.15 milliamps. You can see here. So let us look into the software. So I have written few lines of codes only. So here you can see this pin number 9 is the PWM pin I am using. So here I am writing analog write. PWM analog means pin number 9. So analog write to pin number 9. I am writing a value of 68. So this 68 value corresponds to, you can see here, I have pre-calculated it before. It is 8 milliamps. So whenever we are feeding 68, it is supposed to give me 8 milliamps. So here it is giving 8.15 milliamps. So we need to little adjust this value, then we can get exactly 8 milliamps. So like this, if we feed here 169 milliamps, we should be getting 20 milliamps at the output. So let us load. So here you can see 20.23. So that means little we have to reduce it. Maybe 168. If we make it 168, it will be 20 milliamps exactly. So I have made it 168 now. It is loading. You can see 20.12, maybe 167. So like this we can control field devices using Arduino Uno. You can see. So you can see the gate to source voltage also here. So like this we can control field devices using Arduino Uno. Once again I would like to show the setup. So this is the setup, and here is the Arduino Uno, and the setup runs on a 24 volts DC supply. So like this we can control field devices using Arduino Uno. This is an application of 4 to 20 milliamps or 0 to 20 milliamps current source controlled by Arduino Uno using the PWM pin of Arduino Uno. Thanks a lot. Thanks for watching.